Hello everyone, this is SDS Official and my name is Engineer SD Singh. I will be presenting you with the material of BEEE subject, which is a major subject in the first year of all the engineering branches. Either students study it in their first semester or second semester. There are various topics that we are going to cover with this particular video section. In this particular video, we are going to have some discussion on DC circuit. Now let us start. What is a DC circuit? So as you might be seeing, there is a PPT and we will be having definitions and diagrams in this. Along with this, we will use Notepad to make you properly familiar with the concepts of basics of electrical and electronics engineering. Now, regarding the definition of DC circuit, it is any closed electrical path which is having a DC voltage source as a source supply and any load resistor in a closed path. Let us examine how this happens. So our today's topic is DC circuits. So what is a DC circuit? In a DC circuit, there are basically two major elements. One is the load resistor, which we will be using RL, and one is the voltage supply, which is any DC battery or supply from any DC voltage source. So this is our supply, positive and negative. And if we join this and connect these in series, this is a simple DC circuit, the very basic DC circuit. Now the conventional current flows from positive to negative, so we will be having the flow of current in this direction and we will give the name to this current I DC. So this is the very basic DC circuit and I believe there will be no difficulty in understanding this. Now in all the electrical circuits, electrical and electronic circuits, we need to measure the voltage and currents. We need to measure the voltage and currents. In order to measure the voltage, we have to use voltmeter. In order to measure the current, we need to use ammeter. So voltmeter is always connected in parallel and ammeter is always connected in series. So let us draw another circuit in which we will be connecting these voltmeters and ammeters. So if we need to measure voltage across or voltage from this battery source, we will connect a voltmeter in parallel to this VDC. And if we need to measure current flowing in this circuit, we will be connecting an ammeter in series. So this is the load resistor. In order to measure voltage across this load resistor, we will be connecting this voltmeter in parallel. So this voltmeter 1 and voltmeter 2 will give us the value of voltages and the units of this voltage will be in volts. This ammeter will show us the value of current and the units will be amperes. Now let us discuss about the types of DC circuits. Let us discuss about types of DC circuits. Now, in order to understand types of DC circuits, we need to know what kind of resistive combinations are there. So, there are two types of resistive combinations. First one is series combination and second one is parallel combination, series and parallel. So let us consider there are two resistances R1 and R2. So these two resistances, if connected in series, this means only one end of these resistances are connected with each other. Let us say there are two ends of resistor R1, A and B, and there are two ends of resistor R2, C and D. If I short A and C, if I short A and C, and if I connect a supply between the terminals B and D, a voltage supply VDC, this combination of resistances will be known as series combination. these two resistances are now in series with each other because same current will flow in them, and this particular circuit will be known as series DC circuit. It will be known as series DC circuit. Similarly, if we are having these two resistances R1 and R2, and let us suppose there are two ends A and B of resistor R1, C and D of resistor R2. If we connect A and C with each other and B and D with each other, now these two resistances will be said to be in parallel, because whenever we give supply to either end of these, the current will in both these resistances will not be same. The current in both the resistances I1 IR1 will not be equal to IR2. Let us assume the current here is IR1 and the current here is IR2. These two currents will not be same, but the voltage across R1 and voltage across R2 will be same. So this combination where current divides, it is known as parallel combination of resistances, and such a circuit is known as parallel DC circuit. I hope you have understood this. You can take the screenshot of this particular diagram. Let us move further. Now we have understood there are two types of DC circuits. There are two types of DC circuits, series and parallel. Two types of DC circuits are there, series and parallel. Series combination of DC circuits means there are two resistances connected in series and there is a voltage supply given to them. Parallel combination means we have two resistances but they are now connected in parallel and then there is a supply connected to them. Here current will divide. If, let us say the current total current is I, the current in one resistor will be I1 and current in another resistor will be I2. But in series circuit, the current in both the resistors will be same. It will be I. So this is series and parallel. Now why we have again studied this? Because there is a third type of DC circuit which is known as series parallel DC circuit. It is known as series parallel DC circuit. Now let us move on to this. What is a series parallel DC circuit? As its name suggests, it is a combination of both. So we will connect both type of circuits in this single circuit. This is the series combination R1 and R2, and let us say there is a parallel combination R1 and let us change its name R3 and R4. If we connect supply in such a way, so combining both series combination of resistances and parallel combination of resistances with the DC voltage supply, it will be known as series parallel DC circuits. It can take another forms too. Let us say there are 5 resistances in total. This is R1, this is R2, and in series with this, there is again a parallel combination of resistances R3, R4, and R5. If these three are connected in parallel, now there are two sets of two parallel combinations. A parallel set of resistances 1 and parallel set of resistances 2. This particular circuit, if supplied with the DC voltage, the current will flow in this circuit, and this particular circuit will be also be known as series parallel DC circuit. So whenever there is a combination of series and parallel resistances or loads within a single circuit, within a single closed path, it will be known as series parallel DC circuit. I hope you would understand this. Let us move to the formal definitions of DC circuits and its types. So by definition, the closed path in which the direct current flows is called DC circuit. Now we have already find that the current flows in only one direction because of the unipolar nature of DC supply voltage, and it is almost used in low voltage application. The resistor is the main component of the DC circuit. This is the diagram I have found from the internet. You can search on the Google and there will be multiple combinations of DC circuits. So there is a battery which I represented with DC voltage. There is a switch which can be optional. There is a load which I represented with RL, and it can be any load resistor. Voltmeter is connected in parallel and ammeter is connected in series. Now, these are the types: series DC circuit, parallel DC circuit, series and parallel DC circuit. So, in a series DC circuit, the resistances R1, R2 and R3 are connected in series with each other, as only one end of all of these is connected with each other and another end is connected to the power supply. Now you can notice that the current flowing in these resistances is same. The current is same, but the supply voltage is splits into three parts, or it splits into those many parts as equal to the those many of resistors used. So there are three resistors. The voltage will split into three parts: V1, V2 and V3. So the total voltage is equal to combination of voltages across the resistors. V1 is voltage across R1, V2 is voltage across R2 and V3 is the voltage across R3. Now, according to Ohm's law, which we will study in detail in the later sections, V is equal to IR. If the resistance is R1, current is same, the same equation can be written in this form. V is equal to IR1, which is equal to V1. V2 is equal to IR2, which is equal to IR2 or V2, and V3 is equal to IR3. So the total current and total voltage can be replaced by this equation: V is equal to IR. So we will get sum of series resistances R is equal to R1 plus R2 plus R3. I hope you would understand this. In case of any doubts, you can mention your doubts in the comment section and we will try to clarify that in the next videos. This is the DC parallel circuit. Here, the voltage across the resistances is same, but the current in all these resistors has been divided into three parts. There are three resistances. The current will be split into three parts. Similarly, similar to the previous combination, here the current has been into various parts, but the total current is same. So the equation can be I is equal to I1 plus I2 plus I3, because same current is being divided into three parts. Now, by using the same formula of Ohm's law, which is V is equal to IR, I will be V upon R for the total value of current, or for individual resistances, V1 can be I1 upon R1, V2 is I2 upon R2, and V3 is I3 upon R3. So the equation becomes V upon R is equal to V upon R1 plus V upon R2 plus V upon R3. V is common, that can be cut, and the combination of parallel resistances will become is equal to this. Next is the term for DC series parallel circuit. So here, series and parallel circuits are connected in series with each other, either two parallel combinations or a series parallel combination. A series and parallel combination can be connected with each other, and the resistance can be found out accordingly. For example, here, the resistance between RA and RB can be found by this formula: 1 upon RAB is equal to 1 upon R1 plus 1 upon R2. That has been used in the parallel combination of resistances. Again, for the resistance between point B and point C, same formula can be used and the mathematical equation will become this. So the total effective resistance will be is equal to the resistance between RAB and series sum of resistance between RBC. So you can get numericals based on these. In the next video, we will be doing DC circuit elements. I hope you would understand what we have studied till now. In case of any doubts, I am again saying you can mention these in the comment section. Okay, students, that is all for today, and we will be having next sessions very soon. Thank you very much.